right, welcome to IoT World Manufacturing and Supply Chain Day. My name is Lucian Fogoros. I'm your host for today. And I'd like to thank you for joining us. I'd like to thank the sponsor of this session, the speakers, for being with us. Look forward to your engaging conversations. And I'd like to turn it over to the moderator of the first session, our Board of Advisor member, Hamish McKenzie. The floor is yours.
Thank you very much, Lucian. So good morning, good afternoon, good evening to some of you, depending on where you are in the world, I guess. My name is Hamish McKenzie. Thank you for joining us for today's opening session, which is Revolutionizing Asset Management, Harnessing Asset Master Data, IIoT and AI for Strategic Decision Making, sponsored today by Prometheus Group. First off, it'd be great if you could just tell us who you are, where you are in the chat. It's always nice to get a feel for who's joining us. And while you do that, get settled in, just a couple of housekeeping notes. As I'm sure most of you know, that the session is an hour long. I'm going to be introducing the topic, introducing our guests, and we'll be getting a lot of valuable insights from them, of course, but then we're going to try and leave some time at the end for you to ask your questions as well. But that doesn't mean you have to wait until the end to ask your questions. Please use the Q&A function in the platform that you'll see there on the right-hand side. Just get them in there, not in the chat, because it just makes it easier for us to find them, and it will also more likely you'll get your question answered if you use the Q&A tool. So please do start getting them in there as soon as you have a question pop into your head. Don't wait till the end, and we'll get to as many as we can at the end of the session. All right, so let's focus on the topic at hand then. So we're going to be exploring the critical role of accurate, comprehensive asset master data in bridging the gap between the promise and the reality of IIoT and Industry 4.0. And I'm sure most of us in the room will recognize that there is sometimes a bit of a gap between the theory and the practice. So we're going to be looking into that. We're going to introduce the concept of master data as a service, or MDaaS, as a solution to establish a solid foundation for advanced automation systems. We'll look at how that can help organizations clean, align, and maintain their asset data. And we're going to talk about that approach. We're going to look at how Prometheus looks at that, and their get it clean and keep it clean, and helping so that helps organizations really enable them to fully harness the power of all this new IIoT technology and AI for strategic decision making, as we said in the title of the session. All right, so that's what we're going to be getting into. Before we do get into it, I want to introduce our special guests. So first up, we have Peter Ainsley-Hartwell, who is Vice President of Data Solutions at Prometheus Group, which is a global asset management software provider, I should say. Peter's based in Dubai, and he joined Prometheus Group during his acquisition of Utopia Global in October 2020. His responsibilities include overseeing the development and implementation of the group's data solutions. His journey into technology began more than 25 years ago when, as an engineer, he transitioned a dairy company's environment to SAP after an acquisition. And ever since then, he's been very deeply immersed in SAP, EAM, and data solutions ecosystems altogether. And he's also worked in various roles for 5 years at XL Axiata, which was a leading company, telecoms company in Indonesia. So great to have you with us, Peter. Thank you for joining us. And next we have Jose Favilla, who is Worldwide Director and Partner of Global Industry 4.0 industry platforms at IBM. Jose has 30 plus years of extensive experience working with clients in over 30 countries to help them improve operational and business performance. He has an in-depth understanding of all the asset-intensive industries, including natural resources, process, discrete manufacturing, and he's also an expert in applying advanced analytics, optimization, AI, IoT, and blockchain technologies to drive innovation. He's recognized as one of the world's top experts in this area. He was invited to be a member of the inaugural class of the IBM Industry Academy in 2011. He's chaired at spoken at numerous conferences, published extensively on the subject, won several awards. And when he's not doing all of that, he's also mentoring new talent, MBA students and CEOs. So he's a very busy man. So we're delighted that he's been able to join us as well. Thank you very much for being here, Jose. And finally, a few words about me. I'm your moderator. My name is Hamish McKenzie. As Lucian mentioned at the beginning, I'm an IIoT World Advisory Board member. I'm also a former IDC analyst, and I've been running my consulting practice here in Munich, Germany since 2006. And I help small and mid-sized industrial software vendors dramatically increase their growth efficiency. And I work with them to optimize their go-to-market strategy in all sorts of ways: sales, marketing, customer success, talent management, productivity. If you want to know more about me and what I do, then please look me up on LinkedIn, Hamish McKenzie, Munich. I'm pretty sure there's only one of me here, so it shouldn't be too difficult to find me. As I mentioned at the beginning, please get your questions into the Q&A function, and we'll get to as many of them as we can at the end. All right, so with all the intros done, let's get into it. And before we start the discussion, I think we want to bring a poll up. So Paul, if you can do that, we want to just find out where you are in your digital transformation journey right now. And just let's us get a feel for who's in the audience and what stage you're at, and we can try and tailor the discussion a little bit to that perhaps. All right, so while you complete that quickly, I want to start off with you, Peter. So obviously we're hearing in the context of Industry 4.0, we're hearing a lot about smart equipment. However, there are a lot of companies out there whose equipment they've got in place at the moment is very old, 20, 30, 40, maybe even more years older than that in some instances. So when you've got a lot of legacy equipment like that, how easy is it, or how do you start in terms of getting involved in this new technology, starting to deploy it, and what are the kind of issues that you need to be aware of if you're doing that?
Yeah, and I think that's a very important point, Hamish, that there's a lot of equipment out there that were bought, built, installed before this became widely available, before all of the Wi-Fi stuff became available. But it's getting easier now to buy the sensors. It's getting easier now to install the sensors. But what we need to remember is that the equipment itself is still dumb, right? It still can't talk about and tell people what it is. So it's very important then that whatever system the sensors are sending data to, that those systems know what type of equipment the sensor is actually attached to. The system needs to know that the sensor is attached to a centrifugal pump. It needs to know that it's measuring the pressure of the centrifugal pump, right? It needs to know whether the centrifugal pump has a variable speed drive on it or whether it's being controlled by a control valve, because those physical things impact the sort of model that's going to be built, that's going to be using the sensor data. So it's really important that you start by making sure that when you install these sensors on equipment that isn't smart, right, that you actually make sure that you tell the receiving system what sort of data and what sort of equipment is wrong. It's also then really important to make sure that you have a process in place that says that if the equipment is changed, right, or something happens to the equipment, that you now identify that the equipment has changed, because it may impact the sort of model that's being developed to actually be able to forecast the performance of the equipment. Yeah, because if you don't do that, then all of the time series data and the metadata that's going to be fed to the fancy Gen AI models that you're going to create will be wrong. Right, the model will think that it's getting incorrect data when in actual fact it's getting correct data. Just didn't update the metadata about what the time series data is about. So it's really important to have that process in place to identify when you change equipment or when you change where the sensor is actually attached as well.
And just one small point on that, we were just talking before we went live here about the cost of these sensors has come down a lot as well, right? So this is also made a big impact.
It's made a huge impact. Back when I was doing this sort of stuff, if you wanted to go and take vibration readings, you basically carried a vibration reader the size of a small suitcase around with you and actually stuck the probe on manually, and it would take you 8 hours walking around to do it. Now you can go and buy like a little, penny-sized sensor for Sense, go attach it, connect it with Wi-Fi, Bluetooth, and you're up and running, measuring vibration readings very, 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 very simply. You don't have to run cables all through the factory. You don't have to do all that sort of stuff. So it's now becoming much easier to censor up these dumb equipments, right? But it's also important that when you buy new equipment, buy them with the sensors and stuff already installed, then you don't even have to do anything, right? And then they can be pre-programmed with all of the metadata and everything. So I think the opportunities to get this sort of data are much easier now than what they were a long time ago. Yeah.
Yeah. All right, brilliant. Thank you for that. Paul, can you bring up the first slide, because I think Peter wants to just use this as a reference point. So obviously, we're talking about getting all this information from the sensors and the models that we need in order to to feed then into the Gen AI stuff that Jose is going to be talking about later. But presumably that's not all you need, right?
No, I think that's only the first part. If you look at the slide, what we were just talking about is having the sensor on the motor, having the model that can identify when the motor is likely to fail. And that's all driven by the sensor data. That's all driven by your time series data and making sure that everything is good, yeah? So it's only the first part though. Remember, the whole point of this is not just to take readings. The whole point of this is to try to predict failure and try to make repairs before the item actually fails, right? So once you've identified that there's a possible failure, assuming your model is good, assuming your time series data is good, what happens after that now determines whether you've acted effectively on the information that the model and everything has provided. So if you go ahead then and go and plan your work order, right, but you use the wrong bill of material because you didn't identify that it was a Warman pump versus a Kelly&Lewis pump in the first place. You send the technician out, all right, with the wrong spare parts. Next thing you know, he's running back to the warehouse to try to get the right spare parts. And before you know it, the motor's actually failed, even though you did all of the IoT stuff, even though you spent the money setting up the models and everything. What you really want to do, if you show you the next slide, please, is make sure that all of that subsequent information is correct. So if you know that it's that exactly what the motor is, if you know exactly what the spare parts are, what the task lists are that you need to follow to do the repair, then once you've got the indication that the failure is about to happen, then you can take the necessary action to go and send the technician out, make sure that it gets repaired before it fails, and next thing you know, and then you achieve minimal business interruption, keeping the plant up and running. So it's really important that the first part of that process is terrific. That's what the whole IoT part is about. But if you forget about your maintenance execution and you forget about all that other information that the sensor knows nothing about, if you forget about that, then the process is incomplete and you won't achieve the ultimate result, which is keeping the plant running. Yeah.
Okay. So what different approaches then have you seen in terms of companies, implementing this?
Well, we see various approaches that people take. And I think the first thing to understand is that there's a lot of organizations have a lot of data already in their environment that they're not actually using, right? They've got SCADA systems, they've got data historian systems, they've got all sorts of systems that's already collecting data. So the first thing that we see is use the data that you've already got. Just don't go out and install sensors on everything straight away. Go and have a look at what you've got first and see if you can use that to try to do that predictive analytics that can help you identify when your equipment's about to fail, right? And develop models around critical equipment and processes first. Not all equipment is created equal, right? So make sure that you focus on those items that are critical to your operation. Do your criticality analysis, identify the stuff that is really important, that stops the plant and so on. And if you find then, right, that you've got gaps in the information and you can't do some predictive models with the information you're already collecting, then go and add the additional sensors that you need. So take it as a step-by-step approach. Use what you've already got, identify those things that are critical, fill the gaps with the additional sensors. Of course, remember, not everything needs to be censored to the roof, right? Some things don't need sensors at all. If it fails, great, not a big deal. But other things you should be focused on making sure that you've got all the information you need to be able to predict possible failures. And like I said earlier, if you're buying new equipment, spend a little bit extra maybe and make sure that it already comes with the correct sensors already fitted, and then you can start doing the predictive models from the start. Yeah.
Okay. Okay, good. Sound advice there. Now, another one of these, the buzzwords that everyone's talking a lot about. I mean, it's not exactly new. We've been talking about it for a while. But as with a lot of these things, sometimes it's not always clear to what extent it's actually being used, what extent the value is actually being seen. So and what I'm talking about here is digital twin. So could you just talk a little bit about what that is in the context of manufacturing, and how it works, what the potential value is there?
Yeah. So the concept of a digital twin is to essentially make sure that what you have out in the physical world is actually represented accurately in the virtual world, right? But everyone has a different definition of digital twin depending on who you talk to, right?
Yeah.
And I really see 3 levels of digital twin. The first level is the very base one, and this is independent of IoT, independent of if you've got sensors or not. And that is making sure that the data that you've got in your ERP or your CMMS system accurately reflects the physical items that are out in the plant. So making sure that you do have the correct manufacturer and part number information for all of your equipment, right? You know that it's a Warman pump, or you know that it's a Callion-Lewis pump, a Baldor motor, a Siemens motor, as the case may be. You know what the BOM is. You know what the bill of material is. You've got maintenance plans in place. So this is the base. This is the base digital twin. This is independent of if you're going down the whole Industry 4.0 and trying to do the IoT stuff. You need this information no matter what. It has to come first. It's what actually drives the rest of the process. The second level of virtual twin is what most of the IoT and Gen AI models and everything that Jose is going to be talking about. This is where you're trying to simulate the performance of the physical plant. So this is where you're trying to say, hey, based on the readings I'm seeing, I think that there's a likelihood that this item is beginning to fail, and you need to go and do something about it. But most of this is still driven by analysis, by nice graphs, by some AI, for want of a better word, AI recommendations that come out that say, hey, go have a look at this. Maybe there's something wrong with the bearing on this pump or on this motor, that sort of stuff, right? But it's still very IT focused. It's still very screen focused, right? I think what's the ultimate digital twin, which you've seen in some cases, is like having an actual 3D model of the plant, being inside those 3D models, right? Taking all the information that's been gathered in the base level model and the model simulation level of digital twin, and essentially being able to walk through your plant inside a 3D model, being able to go and look at a motor, right? And literally being able to see the vibration and heat map on a bearing in real time. And as you go and adjust the bearing or lubricate the bearing, being able to see the impact of the work that you're doing in real time through like virtual reality simulation. And I think that's really where a lot of this stuff is going to go. A lot of people think we're a long way away from it, but I don't think we're as far away from it as some people might think. But they're the different levels of digital twin that we see. But remember, the base level, getting the data right, getting the master data right, and that's where Prometheus Group and MDaaS, Master Data as a Service, comes in, is getting that base level right. Because without the base level, the other levels aren't going to work. You need that base core level of data correct before you can move into the more advanced digital twin versions.
And I mean, in terms of the customers that you work with, are most of them still trying to get that base level right, or are people, is that gradually now becoming kind of table stakes?
Most people are still getting the base level right.
Okay.
We're doing some work with companies where we're finding 30% of the equipment out in the plant doesn't even exist in their CMMS and in their right. So people are like, oh, I wonder why we haven't maintained this particular pump, Well, that's because that particular pump's not in your CMMS. So no one's gone and created a maintenance plan for it. It's like, and then we wonder why it fails, right? So a lot of people are still trying to get to that base level. And without that base level, it doesn't matter how fancy your IoT model is and how fancy your predictive model is, right? It's not going to help you if you don't actually know that you've got it in the first place, right?
Yeah.
So most people...
If you allow me, Peter, we did a resurvey with more than 2,000 manufacturing clients around the globe a few years back, and 90% of the data they collected are not used, more or less. They collect a lot of data, as you said, but they're not using the data. That's one.
Wow.
Yes.
And only 20% of the data is used for analytics. I mean, other part is only history, understanding what happened before, etc. So it's still, as you say, long way to go, but people are getting there. I would say a lot of excitement with technologies. As you said, technology is becoming much more accessible, more or less. Ability to put a sensor on the machine, etc. Things that were not possible to do before, now we can do it. It's now a matter of how can we make it happen, pretty much, right?
Okay,
and like I said, we're getting better at it. And people are recognizing that without that core master data in place, it's very, very hard to do the more sophisticated stuff, right? The benefits just by getting the core master data, right?
No, absolutely. All right, just before I move on to talk to Jose about the whole Gen AI picture, you mentioned then just a minute ago that you don't think the ultimate, the 3D model, the virtual reality, etc., is as far away as some people think. Are you willing to put a number on that? Like, how many years are we talking roughly from your perspective?
Well, you've seen some POCs happening already, right? Where people are able to have the smart glasses and go out, and you can read the instructions beside you while you're doing it. You don't need to do all that sort of stuff. So I think we're probably only, 5 years away from, in the really critical industries, of people being able to see that real-time simulation of the impact of what they're doing during the maintenance. I don't think it's going to come to all industries, and it's not needed necessarily in all industries, but I would think that some of the safety critical, processes in some of the safety critical industries, some of the chemical, oil and gas, those sorts of industries are going to move there pretty quickly, I think. And a lot of it's going to depend on the ability of creating the models that we're going to talk about now. Because once you get those models in place, making it available to people isn't that hard. That technology is not that far, not that hard to do. But getting the models in place that can actually show that and provide that to people is where obviously the advancements that's happening in that area are just like exponentially growing, right?
It's
not far away.
Yeah, and I think that's the point. The acceleration, even just using Gen AI outside of what we're talking about, you're seeing the speed of improvement is just breathtaking in the quality of the tool. All right, so let's thank you very much for that, Peter. I'm sure we'll be hearing more from you in a bit, but I now want to move across to Jose and start talking a lot about the topic of the moment, still the topic of the moment, 2 years after it kind of started to go mainstream, the whole Gen AI topic, large language models. So Jose, can you perhaps start talking a little bit about how, in the manufacturing context, we can use this technology to start leveraging IoT data for decision making?
Okay, no, thanks. No, great points from Peter, trying to build on what we're saying, right? So as we hear about Gen AI, we hear a lot about large language models, more or less, right? As the name implies, they are very good to process language, more or less, huge amount of language. I think we all have been playing with ChatGPT and whatever else to have a kind of a feeling for what the Gen AI system can do there as well, right? But the large language models, the whole concept is the following. You have now, instead of building one-off applications, you build a foundation model, right? That's what we call the large language models, more or less. That's a very sophisticated type of machine learning model, right? That's trained before you do anything and can be used for multiple purposes. These models are huge, more or less, right? Just as an idea, the ChatGPT 4.0 is 1.8 trillion parameters, huge, right? And that's the reason companies like NVIDIA, etc., is becoming one of the world's largest company by the market capitalization. They bring the computing power, we call the graphical processing units, to GPUs, to build these models, etc., right? But again, they're built for purpose, and they're very good for dealing with data as well, right? So again, on the other side, if you look at in a manufacturing setup, right, as Peter was saying, you have a lot of data coming from the IoT sensors, more or less, right? I mean, you have this data comes in terms of pressure, temperature, speed, or whatever, right? They come into a forms of time series. So the whole idea now is how can we use the same idea, create a foundation models to deal with time series data? That's a completely different thing that needs to be done. And the large language models are not applicable for this kind of situation. We need a new approach in order to drive this whole idea of, a Gen AI, we're calling, in the manufacturing industries for dealing with IoT data. That's kind of what we are seeing here. In other words, requires a similar idea but different approach to deal with this information.
Okay, the time and the effort to build and deploy and maintain all of these models, it's pretty significant, right? Which could be a limiting factor when it comes to uptake of this technology and implementation and the speed which with which we get to this 3D enabled future. So can Gen AI be used to overcome some of these limitations itself?
Yeah, that's one of the key, supporters of the Gen AI, the whole idea of how can we build models faster, more or less there as well. As we're saying before, every model, if you're using the idea of IoT data, have to understand the equipment itself, right? We have to understand the meaning of the data. We have to build a model for that specific data. And this requires a lot of what we call training data as well. What is good, what's a signal comes good, what's signal comes back, all the combinations. It usually takes like several months as well. But another thing that we have to have been doing, in fact, right, was that for every KPI, for every objective function that we want to analyze, you have to create your own machine learning model or your own model. It's one AI model there to do the equipment. That was the before, right, approach. Typically, this approach took about 6 months or so for implementing, and that's the reason one of the major points was the scalability. How can we build models faster, and how can we deploy them at scale? That was a major limitation of applying AI in manufacturing in particular, because every specific equipment, etc., is unique. So leverage the idea of a master data, etc., and leveraging the idea of creating a Gen AI or a foundation model that are capable of processing this data becomes a critical paradigm change on how we can go about this, right? And not only this, we have been doing a lot of work in this foundation models with time series. We see, first of all, that the models are much more robust. Instead of having to create several models for each KPI, we can create one model that now can understand much better what's happening with the machine, multiple KPIs. The second one, the prediction is more continuous predictions rather than more discrete predictions that we had before, right? The other one is the accuracy of the models. We move it from a mean absolute error from 7% to a kind of 1%. And of course, the time to implement is another very interesting point. We are doing some of the models that we have. We can have the model out of the box with no training, and then we call zero-shot models that you can start already doing some predictions there. So it's quite a game changer, and we see this as a huge possibility to expand now the application of these models across the manufacturing floor as well. So major point about speed and scalability is enabled by Gen AI.
And does this also have an impact on the cost?
Cost as well, right? Another point on the cost is very important because, especially in manufacturing, you have to process this information at the edge, closer to the machine, right? You cannot send it to the cloud, come back, etc. It's not feasible, right? So the idea is these models, we need to create the models that are called fit for purpose. They're small, much smaller than this huge, 1.8 trillion parameters models that we have in ChatGPT, but but it's still good, especially very good to perform a given task in predicting a failure or whatever. We're going to talk about application in a few minutes. But again, it's much, much lower. We are talking about 40 times lower cost than compared to the other ones.
40 times lower. Okay.
Yeah, that's one of the main concerns companies are exploring. Oh, this is going to cost me too much and whatever else. And how can we cannot afford this? But again, this idea of fit for purpose models that can do this specific work around a specific domain, we call this a data modality, like the sensor data, right? It becomes very, very important.
Yeah, and just to add to that, I think we've seen the same thing in our business as well. Like you said, initially these models were right, but now they're trying to, but now they've expanded, so you actually can have a multi-input, multi-output type model, and the technology now allows you to do that. So because of that, you can have a look at the performance of the equipment in a holistic manner, not just look at an individual, and see the relationships between those readings as well. So the technology for creating the models is now much more sophisticated than it used to be. And as Jose said, you get a result much faster. You can trust the result. The accuracy is better. You can do things that you weren't able to do before. And we're seeing that in our experience as well with the sort of work we're doing around asset performance management models and so on. I think it's very important. The technology is helping a lot to improve the accuracy, as you said, of those models and the predictive capability that you can get nowadays.
Yeah, and have been around as you, Peter, for some time. We see the progress of the technology over time, right? As well, right? It's huge, right? In fact, have been around AI topic for entire my career. I was one of the first ones applying AI manufacturing IBM factories when I started my journey with IBM. But again, now what we were able to do versus what we can do now, the art of possible in front of us is very exciting, I would say, right?
Yeah. So I can still remember when AI was called neural networks and fuzzy logic. Yeah. So
fuzzy logic. Oh wow, I haven't heard that for a long time.
I did all of work on fuzzy logic myself.
Okay.
All right, fantastic. So just a quick reminder to people in the audience to please get your questions into the Q&A function. We've had a few, but it would be great to get some more. I don't think I've ever had less than 7 or 8. So I think we've got about 4 now. So get your questions in there. We'd love to get to them at the end of the session. All right. So in these sessions, I always like to try and make it as real and real world as possible. So Jose, maybe you can give some examples of some applications of Gen AI in asset management, where this technology has actually been deployed in the real world.
No, sure, absolutely. So I think obvious application is predictive maintenance, as Peter was saying. I mean, we get information, right? We get the good data from a given machine, etc. How can we predict if there's a failure happening in the machine? That's one very straightforward, etc. But we have been applying this technology across several areas as well. Quality control. I mean, we're testing the quality or predict the quality of a given process in the industry. Prediction for control. How can we optimize a given process, like in cement industry, in steel, or whatever? All these have industry. They have a very energy-intensive process. How can we make this much more effective? How can we enable the operator with this capability so they can now predict a few hours ahead what's going to happen and take actions before they happen? So a lot of stuff happening in this regard, right? So we're applying this. We cannot cite client names, but we are working with oil and gas and asset-intensive industries, of course. We are looking at steel industry, major players in blast furnaces, the electric arc furnaces, etc. Application of the technologies in this regard. In the cement industry, of course, we are working a lot in the kiln, in the ball mill, etc. parts. We are working with semiconductor companies as well. Major players in semiconductor companies are using this technology. Automotive companies across the board. We see a lot of excitement and people that are experimenting are getting some very interesting results. That's one part, kind of how we can use the technology and apply to these processes. The other interesting point that we see across the board, now companies are embedding these into their own offerings. They make it easier for the client to use. IBM, of course, have our own CMMS system called Maximo. We are embedding this whole technology into the product, right? In one of the modules called Maximo Predict, or prediction for predictive maintenance there as well. But we are going, companies are going even beyond. Now we are talking about AI agents that are autonomous, right? This is called agentic AI. Imagine a situation now where you have a failure. Your model detects there's going to be a failure in the machine, and then you need to collect information for what's going to do, how we're going to fix this problem, right? We're going to get the information to guide the technician to do this work. So you need to get information from failure modes and event analysis. You need to get your work order history for that type of machine. You look at, of course, your IoT data. You may have your vibration data coming from another system, etc. How we can collect all this information and analyze this and come up with the right work order process for that specific equipment itself, right? So this is happening as we speak, embedding this into the solutions as well, right? I mean, very fascinating what's happening. And this is happening across the whole Gen AI, across the board. Every company are embedding Gen AI into their offering to make it easier for the end customer to consume this properly.
Okay, and I want to move on in a minute to talk about how companies can potentially get started if they haven't already, or if they're still just experimenting. But just coming back to these real world scenarios briefly, outside of manufacturing, in the kind of regular business world, there's already been a few doubts starting to creep in terms of where's the ROI. So we've been using this Gen AI stuff now for a while, for the last year or whatever. We're still, the leadership of organizations are saying not actually seeing what the ROI is yet. Here, I guess it's a bit more, should be at least a bit more obvious in terms of less downtime, cost, etc. So in terms of the results that people are starting to see already in these cases that you've been talking about, how are they measuring the ROI? What's the most important thing for them?
Yeah, what we're seeing overall, right? Because everyone got excited, more or less, when ChatGPT came up and so on. We have the senior leadership of company. Oh, go there and figure out what this is going to do for us in our business, etc. Everyone started in a kind of rush mode because they were concerned of not doing nothing is not an option, etc. So they didn't start, I would say, in the right approach, in my view. More or less, right? Because it's not only about technologies. Again, it's the old story: people, process, and technology. Technology come last. You need to understand first do you have the right people in the organization that understand the technology, etc., that can even evaluate the right tools to do the work or whatever. But again, people is a very important piece of the puzzle. Companies need to be prepared with having the right people on board, because the art of possible is huge. If you're not acting, you're going to be left behind. Do nothing is not an option. But again, people is one part. The second one are the process. Exactly to the point you're making. Creating new ideas is not a problem. I have a customer that came to us for asking for help. They have more than 40 POCs. They're struck. How we're going to do this into production now? Again, they go back in the POC era where we're not moving from the POC to the production. So understanding the processes, more or less, how we evaluate a given use case, what's the impact to your business, how we're going to measure success going forward. It's part of the process that we needed to understand, right? Another point is not about developing the models themselves. You need to look at your data. The model comes already with a lot of data to use to train the model, but you have to bring your secret sauce, your own data, the data that comes in your factory, comes from you. How we're going to make sure that data, going back to Peter's point, are clean or good and whatever, to make sure that you're using the models right, more or less there. Bringing this additional data to fine-tune the model to your specific application becomes very, very important. In other words, the data is very, very important. The other point is you're going to have, over time, a lot of models in your company as well. How do you govern these models? How do you make sure the models are not drifting or performing well, etc.? How do we have metrics performing the performance of the models themselves, right? And then another thing that's happening quite a lot is our regulatory compliance. I think we all heard about the EU AI Act that's happening, but it's happening across the globe, right? So how do you make sure that you are aligned with the supervised regulatory compliance that's coming up over time? So people need to look at this from a more holistic perspective in terms of what we need to do. It's not only the value of a model, but how we get prepared to go after this space. Right? Yeah. We have been, of course, going back to a very point your questions. We have seen major, improvements in terms of the ROI for the people on a model base, perhaps, right? In terms of, this especially depends on where you apply this. we are talking about a huge amount of benefits, especially in the industry that Peter mentioned, the asset-intensive industries like oil and gas, etc., where downtime costs you a lot of money, more or less, right? And another thing that's happening, we notice quite a lot, companies are losing a lot of expertise. You have these third year experienced engineers retiring, etc. How do you capture this experience as well, right? How we bring a new engineer or new maintenance technicians to fix the problem and reduce the mean time to repair, to bring the equipment back to production as soon as possible. So this is a very huge value proposition that we have. But again, companies need to do it right. It's not only about technologies, it's about people and process together as well. That's my
Thank you. All right, and of course, if you are a very experienced engineer who's perhaps gone into retirement or semi-retirement, you're also in a great position to be then re-employed as a highly paid consultant to teach the new guys.
Absolutely. This is a very important point, right? Because
exactly.
Gap your knowledge.
These models need as a training, right?
Right.
And the training can be training on the data, but what we also find is it still takes subject matter expertise to identify what the root cause is of some of the anomalies that you actually see, right? And that's where the experienced engineers come in. They're the people that come and say, hey, when you see this, this, and this, then that means that this is happening. So you can build that then into the prompts and into the feedback in your model to say, hey, we just saw this. Here's 3 things that you should go and look at, right? So it also speeds up the problem solving and all that sort of stuff as well, and identifying what the activities are that you need to do to go and fix the issue, right? It's really important to have that experience built into the model. Like I said, a lot of us old fellas are going to be retiring soon, so we're going to lose some of the interest, or some of the experience.
Absolutely.
All right, good. So last chance to get your questions in, folks. We have got a few more in now, so I'm going to try and get to them as quickly as we can, as many of them as we can at the end. Before we do that, I want to start with Jose, but from both of you, get practical in terms of companies who want to get started on this journey. What can they do? So from the IBM perspective, Jose, can you talk a bit about that?
No, sure, absolutely. First of all, I think we believe, right, that AI needs to be open and trusted, because if you don't trust on the AI model, what are you going to do, right? I mean, so from this perspective, we create an alliance, IBM and Meta, with another 50 other members. We call AI Alliance. It's an open alliance. We have major companies like Dell, ServiceNow, you name it, right? I mean, Linux Foundation, we have major universities in the US, universities, Berkeley, University of Tokyo, Notre Dame, all these people collaborating into bringing AI to be available to everybody, more or less. So maybe take a look at this, called AI Alliance. You can Google this. You may want to consider to benefit your company, understand what's going on, and figure out how we can leverage this technology. That's maybe one recommendation. The second one, perhaps, is to get your hands dirty. In fact, IBM, we open source the models that we are talking about, the time series, and they are available in a repository called Hugging Face. It's a repository for all the AI open models that companies have. You can go and download the models for free. You can play with the model, of course, and figure out what's happening, what happened, etc. In other words, try just a little bit. Maybe get your data scientists playing with this thing. Would be good. Not only IBM has models from Meta there, etc. Again, is available for you at no cost first, right? And the third part is really understand your company, make a little assessment about your readiness to have the right people, to have the right data scientists or whatever that can understand these technologies. What are the processes, at least the minimal process you have to put in place to evaluate and make sure that you're doing it right as well. And the other one is about, start thinking about a platform. I mean, because there's a lot of things out there that are available. What would be a kind of enterprise-ready data platform? Doing this at home, a ChatGPT one thing. Doing it at the company is another ballgame, right? So understanding that, data, regulatory compliance, all these other pieces are important parts of the puzzle that you need to consider. That's the way. But again, in a very simplest way, go and download the models and play with the models to figure out what they can do for you now, more or less. But that's the idea. Okay.
Fantastic. Thank you very much, Jose. And Peter, from your perspective, what would your advice be to customers who are looking to get started on this transformation journey?
Yes. So like I said, I think the first thing is to identify what's critical. Everyone can have a list, arms long list of things that they might want to try to do. But from what we see is the people that are most successful become very focused. They don't try the shotgun approach. They do the sniper approach, right?
Okay.
Let's focus on the equipment that is absolutely critical to my process. Let's focus on getting those models accurate, and let's make sure that we get some runs on the board and we can show the value of putting these predictive models in place, show that ROI, and then it's very easy to convince people that you need to extend it further after that. But pick something that is meaningful. It's always a balancing act to pick something that is critical enough in the process, but simple enough to make sure that you're going to be successful, right? But not so simple that people say, yeah, whoopee-doo, right? It didn't really do anything that we weren't doing before. It's got to be adding value. So as I said, pick something that's critical in your process, pick an equipment that's critical, focus on that, get that right, and then extend it out. Don't try to do everything at once. You just won't get the time and the focus to be able to get it right if you're trying to do everything at once.
Yeah, no, great.
My recommendation. Be very laser focused on.
Yeah, and this is, I think, what Peter was saying is extremely important as well. I mean, focus and get this thing done to show that is the art of possible. But also, we need to come up with a good maintenance strategy. It's not only one size fits all, as you're saying. There might be assets requires a lot of attention. Maybe pick the ones where we can see the value. There might be others who are going to run to failure because they're not care. I mean, whatever. So understanding your reliability-centered maintenance strategy for the company becomes a fundamental piece. It's not only one size fits all understanding. And prove early would be very, very important to show that the art of the possible and gain buy-in within the company. Also very, very important as well.
Yeah, doing that criticality analysis, like the RCM stuff. If you've got a piece of plant that you've done the RCM and you've decided that it's a run to failure, then what does it matter? Don't spend any time on it. You know it's going to fail. Be prepared when it fails. A lot of people think, oh, that means we haven't, done our maintenance strategy. Yes, we have. We have a maintenance strategy which is run to failure. So you know it's going to fail. Don't be surprised when it fails, but be prepared when it fails to fix it as quickly as possible. Right? Yeah. That's the strategy you need to have in place if you have a run to failure. But where you've got a critical piece of equipment and you don't want it to fail and you can't afford for it to fail, then spend the effort putting in the models and doing what you need to do to try to predict it, and then do the repairs before it actually becomes a failure. Yeah,
absolutely. All right, thank you. And yes, just going back to your point about not trying to do everything at the same time, goes back to one of my favorite pieces of favorite comment about multitasking, which is that multitasking is really just the ability to screw more than one thing up at the same time. So really, the importance of focus and step by step it can't be overemphasized. I think in this as in life generally. All right, so we've had a few questions come in. I'd like to get through a few of them in the last 10 minutes or so. I'm going to try to get people's names right. Pronunciation is sometimes a little bit tricky, but I'll do my best. So I apologize if I don't get it 100% right. So there's one here from Ala Majub who says, why are foundational models used in the context of industrial applications like manufacturing digital twins, given that model hallucinations are unacceptable in such settings? So the big hallucination issue. Does one of you want to tackle that?
Yeah, well, the hallucination, I would say, is one thing we see in the large language models, more or less, right? I mean, the large language models can go on tangents with an answer that's not right? So in manufacturing in particular, we have, I would say, different data modalities that we needed to get a model fitting for that purpose, more or less, right? One is, again, the time series data is one data modality. And again, before we put the model in production, we have to test it properly and whatever to avoid this, but there's no hallucination on on that sink, I would say, there, right? The other part is image, right? How we can use images to detect a kind of a situation, more or less, right? In terms of what's happening, not happening, the product quality, the inspecting a physical plant, more or less, right? So image is another area. Again, we have a fit-for-purpose models to look at, to deal with images in a factory setting, more or less. Understanding, in fact, we did some work with a robot, in fact, where a robot walks into the factory and the robots understand, they do like 100 inspection points, let's say, in a factory, and the robot can read dials, can look at infrared cameras to look if this is hotter than was expecting, this equipment and so on, and start open work orders already in the system for someone to take a look afterwards. So again, this idea of visual understanding the environment and whatever else, and even automate somehow how we are collecting information is another important angle to consider there as well. And to have, of course, the large language models fit for purpose in an environment of manufacturing. So what we did, we kind of pre-trained the models to some extent to understand the domain of manufacturing. Because one is to get ChatGPT that has nothing to do with manufacturing and start fine-tuning the model. But we understand that the model will need to understand more like a piping and instrumentation diagram. Is another important point. How can we understand what's happening? How we can help a process engineer diagnose a problem with the whatever equipment, a sensor or whatever. We look at the failure mode in event analysis as well, information. We look at troubleshooting manuals, understand what a PLC means, etc. So whenever you ask a question, the model understands which application or which PLC you're going to get the data from, more or less. Understand this domain is a one level of a pre-tuning before you finally deploy the model to make sure that we have I'm calling a LLM form industrial available there as well. So that's the work we're doing to facilitate our clients to somehow deploy this faster without having to go through the whole, starting from just using a base foundation model based on language, etc. So understand all these nuances in manufacturing is becoming very, very important.
Okay, fantastic. So just staying on the digital twin topic for a second, we have a question from Hemkant Yele. How can the integration of digital twin and the connected machines that Peter was talking about help to improve system efficiency overall? You want to talk about that, Peter? Or
yeah, I can do an initial response, and I think it's really important that the whole digital twin and connected machines forms an end-to-end process, right?
Right.
So you need to make sure that when you talk about the efficiency of the system, you're talking about the efficiency of your production, you're talking about the efficiency of your maintenance technicians, only sending people out once to fix the problem, not having to send them out 3 times to fix the problem. And by having those models and having that connected machine, you can actually then ensure, say, hey, we sent someone out to fix the problem. Before they leave site, right, you can actually confirm that the problem's been fixed, that the equipment's back operating within its envelope that you expected it to be. You don't have to wait. So I think being able to have that combination of the digital twin, the connected machines, enables you to improve that feedback loop that says we fixed whatever the problem was that we identified, and we can get go move on to the next item. So that's one of the areas where having both aspects, the model and the connected machine, pays big dividends, I think. Yeah.
Fantastic. Okay, thank you for that. Okay, this next one is from a technical perspective definitely way above my pay grade. Hopefully not yours. It's from Sarita Charles Cole. Fantastic name, by the way. How can advancement in sensor technology enhance real-time monitoring and data collection in industries like agriculture or tea production, very specific? And what challenges remain in integrating these sensors seamlessly into blockchain-backed traceability systems? Can either of you give some insight into that one?
I don't know. You want to take a step or either one? I think we lost your audio, Peter.
I think you can have a go at this one, and then I'll add some comments. Yeah.
Okay.
Before it's okay. All right.
Yeah.
So as Peter was saying, putting sensor now becomes not a very expensive task, first of all, right? But again, understand what exactly you're going to measure becomes a very, very important point. Not put sensor everywhere, but understanding the right sensoring strategy becomes this. Of course, that's one. Then once you have the information coming, of course, you need to make sure that you have a kind of master data to understand the meaning of the information first. What does it mean having this temperature from this part of the process, a temperature, another part could be quite different, meaning understanding the master data becomes this to make sense that you get the information from the data itself there as well, right? So in other words, understand what we're measuring because it's important and make sure that we have the semantics of the information coming becomes another very important. Now comes the next question, what we're going to do with it more or less. What are the actions you're going to take? You can look at, again, look at the whole spectrum of analytics, look at the reporting. I mean, am I growing my stuff or whatever in the right way or not from a reporting perspective? What's happening now? You may say that maybe we were expecting to have some rain, but we're not rain. What's happening in the actual degradation of the agriculture stuff happening there could be another one. What may happen in the future? Now, predicting something that we have to do. If we don't have the right watering or whatever, you may have a situation now that we need to do. What can we do to avoid this to happen going forward there as well? So there's a lot of things. And then comes to the blockchain. Blockchain, again, is a single version of the truth, right? Where you can go all the way to where the let's say, we usually say from the farm to the fork in IBM. We have a blockchain platform covering this whole ecosystem, more or less, to make sure that every piece of information being fed into this blockchain is validated as well. And sometimes you have to eliminate the human touch on this one. If you can get information directly from the sensor, what's happening, etc., it's a much more reliable information than someone trying to do a little massage on the information before feeding this. And this becomes, of course, the one version of the truth that you can now trace back the information all the way back to where it starts. If you are in a supermarket buying a product, you know exactly what you can maybe use the barcode or whatever, understand the whole history behind what happened with that product. If someone is talking about this is an organic product, yeah, you can trust fully that's what you're buying is the right things. That's kind of the way I see in a very simplified way, right? Again, starting with the instrumentation to get the data, understand it is, and then what kind of analysis you're going to be doing on the topic, whatever makes sense for the company.
Okay, Peter, anything to add on that?
No, one small thing, it also enables you to make sure that from a regulatory point of view, that things have actually been done as they were meant to be done as well. So you can actually check that, you know, things like preventative maintenance routines were done in the time that they were supposed to be done, that you didn't exceed certain temperature or pressure settings during the processing process. So you can now validate that everything that led towards achieving the correct level of quality has actually been done as well. So it helps a lot being able to do that validation, as you said, that all the steps in the process met the specifications and the requirements of that step. Yeah, I think that's really important that you can actually do that validation. As you said, that's what blockchain is meant to do, right? To validate every single step. So
every test and whatever else have to, again, another piece of information to be fed in the blockchain to make sure you have everything there.
Exactly.
Okay, fantastic. So unfortunately, we have run out of time. What I can promise to those the people who've asked questions we didn't get to, please don't be concerned, because we will get the panelists to give you a short answer afterwards we'll arrange for your question to get answered via email. So sorry we couldn't get to them all. All that remains for me to do is to thank our panelists, Peter and Jose. Thank you very, very much for all your insights and knowledge. Thank you again, particularly to the sponsor, Prometheus Group. Without you, sponsors like you, we don't have the opportunity to put on events like this, and the audience doesn't get the value that we're delivering. So thank you very, very much for that. Thanks for all the attendees, the questions, and it's now time to move on to today's next session, which is Future-Proofing Factories, Strategies for Adapting to Rapid Technological Change, sponsored by Arch Systems. So please enjoy that. I'm hosting another 2 sessions later today, so hopefully see you later. Thank you very much, guys, and have a great day.
Have a great day.
Thank you very much. Take care, everyone.